Hello children, our topic for class 10 today is polynomials. Okay, we have learned this chapter in class 9. Okay, let us recap what we have learned in that class 9. Okay, first we dealt with constants. Remember, constants, what are constants? Constants are terms whose values do not change in any circumstance. Examples of constants were real numbers, say number 10. Now, any real example would be all numbers because they will not change their value under any circumstance. Okay, then we have variables. What are variables? Variables are denoted with the help of the alphabet, and they change their values in different circumstances. Okay, they take different values in different circumstances. So, variables and constants together, they form expressions. Okay, then in expressions, if the power of variables, of all the variables in the expression, are all whole numbers, then expressions become polynomials. Okay, now take for example, we take x cubed plus 3x squared minus x plus 1. If we take the powers of x, they are all whole numbers. So this expression will become a polynomial. Understand? Now for example, you take this x plus root x. Now, do you think this is a polynomial? Let's check. What is x plus root x equal to? X plus x power half. So, what is the power of x here? It is 1, which is a whole number. What is the power of x here? Half. Is that a whole number? No, it is a fraction. So, when this happens, this kind of x plus root x will not be a polynomial, but it will only be an expression. Do you understand? The same goes for negative powers. Just say we have x plus 1 by x squared. Is this a polynomial? Let us check. What will this equal to? X plus x power minus 2. Now, minus 2 is not a whole number, so this is not a polynomial. This becomes only an expression. So, do you understand? Expressions will become polynomials only if the powers of the variable are all whole numbers. So, in that case, is a constant a polynomial? Yes. Why? If I take the constant 7, is it a polynomial? Yes, because it can be written as 7x power 0, where 0 is a power of x, which is a whole number. So, this will be a polynomial. So, these are constant polynomials. This is a polynomial also, but these two are not polynomials. So, have you understood the difference between expressions and polynomials? Okay. Now, polynomials can be classified with the help of the number of terms in the polynomial. Say, supposing we have 7x. Now, how many terms are there? There is only one term. In that case, it is called a monomial. Right? Now, if there are two terms, just say we have 7x squared minus 1. There are two terms. In that case, it becomes a binomial. Okay? Then, if there are three terms, just say we have x cubed minus plus x squared minus 1, like that. Okay, whatever. There are three terms. In that case, it becomes a trinomial. Now, if there are more than that, we call it a polynomial. Actually, poly, the word means many, right? So, more than one itself, we can call it a polynomial. Are we okay with this? So, we have classified polynomials based on the number of terms in the polynomial. Now, let us go to the other type of classification based on the degree. Now, what's the degree of a polynomial? Supposing I have a polynomial 5x squared minus x plus 1. Okay. The highest power of the variable is known as its degree. So which is the highest power in this case? For x it is 2. So that implies it is of degree 2. Okay. Now supposing I have 3x minus 6. Now in this polynomial, what is the highest power? The highest power of x is 1. So the degree is 1. Okay. Supposing I have 2x cubed minus 3x squared plus 5x minus 7. Okay. Now what is the highest power of x in this case? It is 3. So the degree will be 3. Okay. Now based on the degree, we can classify the polynomials as, when the degree is 1, we call it a linear polynomial. What is it called? Linear polynomial. When the degree is 2, we call it a quadratic polynomial. And when the degree is 3, we call it a cubic polynomial. So, have you understood that the classification of polynomials based on terms, we have monomial, binomial, trinomial, etc. Based on its degree, we have linear polynomial when it is degree 1. When the degree is 2, we call it a quadratic polynomial. And when the degree is 3, we call it a cubic polynomial. Okay, this is all what we have learnt in class 9 earlier. Now, let us come to the zero of a polynomial. Now, what is the zero of a polynomial? The zero of a polynomial is, just say there is a polynomial p of x. Okay, and if the value of p of x becomes 0 for some value of x, then that value is known as the zero of the polynomial. Let us have one example. Just say let p of x equal to x minus 3. Okay. Now, when will this polynomial become 0? We find that it will be p of 3. Just say we say let x is equal to 3. So what will happen? We'll get 3 minus 3 equal to 0. In that case, the zero of this polynomial is 3. Because when we substitute the value 3 in the polynomial, we are getting 0. So in that case, 3 becomes the zero of this polynomial. Now supposing we have a polynomial like this, p of x is equal to x squared plus x minus 2. Okay. Now we learned to find the zero of this polynomial by the trial and error method, right? So let us say let x equal to 1. If x is equal to 1, what do we get? That implies p of 1 will be 1 square plus 1 minus 2. So you will get 2 minus 2 equal to 0. So what is the zero of this polynomial? 1. Do you understand? So this is how we find the zeros of the polynomial. Now, when we are finding zeros of quadratic polynomials and all, we'll have to start with p of 0, p of 1, p of minus 1, p of 2, then p of minus 2, like that. We have to go on till we get the answer, right? That is what we did in class 9. Now let us see, in case of a linear polynomial, one easy method of finding the zero is equating the polynomial to 0. Now which is the polynomial? X minus 3. Supposing I equate it to 0, what will I get my value as? X is equal to 3 on transposing. So it becomes easy for me to see that p of 3 will be 0. Do you understand? So for a linear polynomial, the standard form is p of x is equal to ax plus b, right? So how will I find the 0? By equating the polynomial to 0. So what will I get? I'll get ax plus b equal to 0. So what is ax equal to minus b? So that implies x is equal to minus b by a. Now let us see if this, when we substitute here, we'll get 0. See, that implies p of minus b by a is equal to a into minus b by a plus b. Correct? So if I cancel out the a, you'll get minus b plus b equal to 0. So we have got this the value, the 0 of the polynomial by equating the polynomial to 0. This is for a linear polynomial. For the other polynomials, of course, we have to go in by the trial and error method. Okay, or by solving that polynomial. Now let us see the geometric representation of a polynomial. If you take a linear polynomial, we know that it will be represented by a straight line, right? So when we represent a straight line in the Cartesian plane, what do we get? When we represent a straight line, we will notice that it cuts the x-axis at one point. So that will be the 0 of the polynomial. So when it is a linear polynomial, it will have only one 0 because it is cutting the x-axis at one point. Now in case of a quadratic polynomial, we find that the resultant representation geometrically will be like this, something like this. So what will happen when you get a curve? It will cut the x-axis at 2 points. So how many zeros will that polynomial have? It will have 2. Okay. So we can find the number of zeros of a polynomial by seeing the number of times it cuts the x-axis. So if p of x is the polynomial and it is represented like this, just say, to find the number of zeros, we can see how many times this curve cuts the x-axis. How many times does it cut it? 1, 2, 3, 4, 5. So how many zeros will this polynomial have? It will be number of zeros is equal to 5. So we can find the number of zeros by seeing the number of times it cuts the x-axis. Are we clear with this? Okay. Now this is a sure 1 mark question. So I would like all of you to understand what we are doing and attempt it. See, supposing we have a curve like this. Something. Now, how many times is this curve cutting the x-axis? In 1 point. So this p of x will have how many zeros? Number of zeros is equal to 1. Okay. Now supposing I have a curve like this. This p of x, how many zeros will it have? Yes. If you see, it is not going to cut the x-axis at all. So the number of zeros of this will be equal to nil or 0. Have you understood? So I will give you some questions where you can find the number of zeros based on the geometric representation of p of x. Understand? So please do your homework. You'll find it easy and understand the concept. It's a sure 1 mark question. Have a nice day. Stay home. Stay safe. Thank you.